In this lesson, we shall focus on mathematics for intermediate phase. Right. The MIP 1502 and 1501 simultaneously. Okay, normally we switch between the two modules. Right, so in question 2 now, we're still discussing question 2 when there was a disturbance. And right now we're right back at the question. Design your own equations on distributive property, 2 equations, and associative property, 2 equations, and explain it to grade 4 learners by giving solutions to each. Okay, so to design 2 equations for distributive property, we note that the distributive property. Okay, right. We start with the distributive property, and then we can come to the associative property. Right. So the distributive property is very important to state what the distributive property actually states. Right. By the distributive property, we mean that if we have A times B plus C, it is AB plus AC. Or you can say that B plus C, does it matter, is equal to BA together with what? Together with CA. Get the point. So that sort of becomes the distributive property. Okay. But now, obviously, being the distributive property, we need to give our own equations on the distributive property. So now the equations we're giving are as follows, right? So we're going to say, for instance, 2, open bracket, 3 plus 5. Right, 2 open brackets, 3 plus 5 is going to be 2 by 3, 2 by 5, and then we're able to see that the 2 by 3 is 6, the 2 by 5 is 10. The result is actually 16. Right? Yeah, good. So now we actually obviously can give another one because we need to give 2 of them, or we need to give 4 into 5 plus 2, and then you have 4 by 5 plus
5 and 2 by.
What is 4 by 5? 20.
It's gonna be 20.
28 is the result. You agree?
All right.
Okay. So what do we do now? We explain. Right, because we need to explain it to grade 4 learners by giving solutions to each.
Yes.
Right. So obviously, the explanation. Right. So the explanation is as follows. Right. In the explanation, we say that to perform distribution, so we say we can use a very short expression like we're saying. Bode's rule is used to expand, right, and remove the brackets.
Brackets, yes.
Yes, and remove the brackets in each case. In each case, in the equations above. Right, in the equations above. And then addition is used. Right, and then addition. Right, so then we use Bode's rule to remove the brackets, and then addition is used. Right, is used to obtain the final result. The final result. Okay, so obviously, I mean, that is one way to explain the fact that Bode's rule is used to expand and remove the brackets. Okay, the removal of the brackets, in each case, in the expansions above. And then addition is used to obtain the final result. Okay, then we use addition to obtain a final result. In each case, so I mean that would be sort of adequate to really explain what is happening, you know. In this case, in which case, therefore, that explains the distributive property, but it's not only the distributive property, but it also have the what? The associative
The
property.
associative. Yes.
Yes. Right. We also have the associative property. Okay, by the associative property, obviously, we know that if you have A plus B like this, C, it becomes A plus B together with C like this.
Yes.
So now, this is the associative property. So let's give two equations. And then we shall explain, because the explanation is very collective. It's very descriptive of both than really to explain each one. So in each case, you have, for instance, 2 plus 3 plus 5. Okay, if you want, you can give them like that. And then say 5 or 7, just any numbers. So you're just generating the numbers here. 7 plus 2 plus 4. Let's look at the solution. Okay, so if you look at the solution, we have the following. You would say, right, or the solution, or we can call it the solutions. So we have 2 plus 3 and then plus 5. Okay, solution would be 2 plus 3. Obviously gives us a 5 plus a 5, which gives us a 10. And then we have the other one, 7 plus 2, which is 9 plus 4. And then you have exactly 13 like this.
Okay.
Okay, so yeah, we have exactly that. So now, I mean, let's give a brief explanation. It's not a lot of words. Simultaneously, we're dealing with grade 4 learners. So it's not that we're dealing with graduates here. Okay, right. So what that means, this means is that the explanation is just also say remove brackets by using Bodmer's rule. Okay, remove brackets by using what? Bodmer's rule. And then, okay, let's write a standard end. And then use addition. We used addition at this point, and then use addition to determine the final answer. The final answer. So yeah, that's exactly what we did. So that's what we get. So obviously that will be one way to sort of explain what is happening, but yeah, it's very, very adequate.
Sorry, can I
Yes.
ask something? Because you said we should remove brackets by adding Bodmer's rule.
Yeah, by using
I think for
Bodmer's rule.
for a
Yes.
grade 4 learner, if I think it's gonna be easy if I say follow the Bodmer's rule by adding the one in brackets first and then adding the remainder.
Yes, yes,
grade
yes.
4, if you say remove brackets, for
Yes.
grade 4, they will remove all the brackets and add them, and there will be like 7 plus 2 plus 4.
Yes, yes, yes. Yeah, definitely. You're
That's what
right.
I'm
You're
saying.
right. You're right. So obviously, I mean, there are all sorts of interpretations. I mean, you really are on point. Alternatively,
Yes.
you can say that perform addition
Yes.
by first adding the numbers within
The brackets.
the brackets. Okay, by first adding the numbers within the brackets, and then finally add the last two numbers.
Yes.
We'll finally add the last two numbers. Okay, so and then we finally add. So perform addition by first adding the numbers within the brackets and then finally right, and then finally add the last two numbers. Okay, so in
Yes.
this case, I mean that is one way to explain it.
Yes.
Yeah. Or you can just there are many ways. You can just say add the numbers in the brackets first. In the brackets what first? And then okay, yeah, add the numbers in the brackets first by using Bodmer's rule.
Yes.
Yeah, add the numbers in the brackets first by using, I said I mean, all these are correct.
Yeah, they are
Right,
all
yes,
correct.
yes,
They are all correct. Just that a grateful learner won't think out of the box.
of course. I agree,
Yes.
I agree. Yeah,
Mm.
add the numbers in the brackets first by using Bodmer's. Right, Bodmer's or PEMDAS. All right, so add the numbers in the brackets first by using Bodmer's rule. Right, and then proceed to add the last two numbers.
Yes.
The last two numbers. So yeah, we have that. So it's okay. All right. So yeah, so just think of that and see what you can do.
Okay.
Okay,
Yes.
yeah, but yeah, I mean, all these are correct. You'll get marks there.
Yes.
Because we are all describing the same thing, but yeah, it depends on which is much clearer. Okay, right. Let us continue with our practice. It is my hope, therefore, that yeah, this is going to be much clearer. Let's continue. Okay, we actually, need to spend more time also on equations, and we'll recap on some of the equations we learned, and also we'll strengthen what we've learned. Okay, for example,
Okay.
We will actually look at this in sort of all sorts of different ways, and in an attempt to make sure that when the exam comes. There's much more familiarity with these kinds of things, like represent the real numbers from 2 to 7 inclusive. Okay, let's see that. So yeah, represent real numbers from 2 to 7 what? Inclusive.
Inclusive, yes.
Right, so now if you look at the numbers from 2 to 7, inclusive, but first you must write it in set builder notation. So what is set builder notation? Right, remember these are what? Are real numbers. You need to represent real numbers. So it means that there's a number x which is real, right? Because these are real numbers, but they're from 2 to 7, such that the numbers, okay, so there's an x that is an element of real numbers, but it's from what?
Yes.
The numbers are from 2 to
7.
Right. So in other words, then we have something like this. But because it is inclusive, means that you can have the equality here. So the 2 is less or equal to x and less or equal to 7, like that. So this becomes true because of what? It becomes true because of the set builder notation.
Okay.
Right. So now let's explore this and see what we can do in the next question. Right. let's attempt to do this one in the next question. Like in 2.1.2, what do we do there? If we also sketch on a number line, can you sketch this on a number line? Yes, we can.
Yes, we can.
How would we sketch this on a number line? Oh, there are many ways to sketch this on a number line, but these kinds of numbers we're dealing with are real numbers. Okay, how do we sketch it if it is integers? Okay, we first look at the fact that these are real numbers and therefore we need to sketch the real numbers. So if we sketch real numbers, we're going to look at, okay, here's the number line like this. From 2 to 7, we can just put the numbers we want and inclusive like this. Okay, 2 to 7 like that.
Okay.
You get the point?
Yes.
Yeah. I mean, this is how we could do it on the number line, but we know very well that there are other ways, like 2 to 7, and then you can have this. Okay, and then this normally is called axis, the horizontal axis. It's called the x-axis. So in which case, therefore, like in the Cartesian coordinate system, now we'll just be only having the horizontal axis, which is our x-axis, which then will just be missing the vertical axis. Because in our usual Argand diagram, there are a couple of things that happen, or what you call the Cartesian plane, would have both the y and the x. And these are real numbers that have been put together such that they are orthogonal to each other. Okay, so it's something that we take note of. But now, yeah, we are saying the sketched on a number line, right? So the number line sketched would be the 2.1.2, which will exactly be that one. Okay. Yeah, that is something that becomes very, very important there. So take a look at that and make sure you understand that. The interval notation, yeah, the interval notation. How would you write this in interval notation? Okay, interval notation. What is the interval notation? Right, so we recall that sometimes I'm going to give you a chance to participate because it's not fair. It is not fair not to give you a chance. It's not fair not to give you a chance. I mean, yeah. In today's teaching, okay, this just jumped because there's a previous recording that has been captured, so that's the reason why this thing
is it complete?
No, it's a recording of my previous discussion. I had an early discussion, so this thing is just popping.
Okay.
It's just popping the discussion, so yeah, it's just popping discussion. That's fine. So we're looking at the interval notation. Okay, so now if you look at the interval notation, what then do we do? Okay, we are effectively then saying we have learned the interval. What is an interval? What is an interval? Interval. Right, now an interval would be x element of the interval 2 to 7. Like this, inclusive, and then you put the square parenthesis there.
Okay.
So this will be descriptive of an interval that is from 2 to 7, but inclusive. Right, and this constitutes what we call the interval notation. It constitutes the interval notation. So yeah, we're emphasizing the notion of an interval. The notion of an interval. So we will participate here. And now sometimes I'm going to give you a chance to talk, because yeah, a student in today's learning strategies, we believe that teachers should not be only dictators in class, but they should be facilitators. They need to be facilitators. They need to facilitate learning. They should not just be there to dictate and just give answers, okay? But they need to, or just give notes only, but they need to engage the learners. In particular, we say that teachers must allow learners to construct knowledge. You get the point?
Yes.
So there has to be a form of what you call constructivism.
Okay.
Okay, so we continue.
Yes, we continue.
Okay, let's look at the next one. 2.2.1. Right, we must be able to solve the inequality. Yeah. We're going to use standard strategies to solve the inequality. Like, if you look at this inequality, what is the inequality? It is exactly this one here. Okay, in this inequality, what do we do and how do we solve it? Okay, first things first, I'm going to write the inequality up here. So if we're given, for instance, 2x minus 3, which is divided by what? Which is divided by 2, and this is greater or equal to, yes, 3, open bracket, x plus 1. What do we do first? What is the first thing that a student is supposed to do when solving this inequality? There are many things that a student can do. Okay, that's the first thing. But one thing that is popular is to get rid of fractions. Okay, now the attempt to get rid of fractions, because there's a fraction here, like 2x minus 3 over 2, it's like a fraction. So there's a tendency to remove the fraction. How do you remove fractions? That is the question we're asking. How do we remove fractions? You multiply by 2 here. You have 2x minus 3 over 2 greater or equal to, also multiply by 2 by 3x plus 1. So you can multiply both sides by the LCD.
Okay.
The 2 becomes sort of our lowest common denominator. LCD in our lowest common denominator becomes what? Becomes 2. Okay, take note of that. And we multiply through by the LCD and we get this particular result. So that in the end, the 2 cancels. And we have 2x minus 3 is greater or equal to, what is 2 by 3? It is 6x plus 1. And then we have 2x minus 3, which is greater or equal to 6x plus 6. Right, which is then, what do we then get? It's greater or equal to, then we have 6x minus 2x, and then we have minus 3 minus 6. What is minus 3 minus 6? It is minus 9, which is greater or equal to 6x minus 2x is what? It's exactly 4x. So we're having minus 9 is greater or equal to 4x, and then you, yeah, okay. Now, okay, what do we do here? Okay, what do we do here? So now, in other words, if you have, for example, 4x is less or equal to minus 9, how do you solve this? How do you solve this?
We're gonna have to add it.
I'm just giving you a chance to, to explore. So I'm saying that I know that we can solve this. Okay.
Yes.
Right. 4x is less or equal to minus 9. This is sort of what we got here. But you see, the question is, how do we solve this? What do we do? Either this or that, you know? We spoiled for choice. We have 2 of these. But what do we do to solve for x? We need to solve for x. That's the question. Solve the inequality. This is a past exam question. Solve the inequality. So how do we solve the inequality? Okay, just
we're gonna,
yeah.
Yes, it's I'm not too sure, but aren't we supposed to add them together and then remove the x?
Okay, yeah, because you see, the thing is that where are we? Where are we? We are here.
Yes.
We got to here, and we got minus 9 is greater or equal to 4x, which in this case you can still write minus 9 is greater or equal to 4x. Or you can read it from the right to the left and say 4x is less or equal to minus 9, 4x less or equal to minus 9. And then at that point, you attempt to solve for x. Yeah, so you multiply by 1/4. Okay, what we do is multiply by the multiplicative inverse of 4.
Okay.
Okay, and that is the point I was trying to drive towards. So we multiply by the multiplicative inverse of 4, and the multiplicative inverse of 4 is 1 divided by 4. So now, if you multiply by 1 divided by whatever you do on the left must be done on the what? On the right.
On the right as well.
Yes. Good. Now we have that. So at the point that we have that, we perform multiplication and that. Cancel this and we have x. And we have minus 9 out of 4. Minus 9 out of 4 becomes the result. So, I mean,
Okay.
this becomes the answer to the question. Is this answer correct or not? So you can check if this answer is correct. Like it is saying x is less or equal to minus 9 over 4, but you agree that the number minus 9 over 4 is less or equal to 4 goes how many times? 2. Okay, it goes 2 times.
Yes.
And what is the remainder?
It's 1.
1 out of 4. Okay, something like that. So you have x is equal to minus 2 and 1/4. Okay, so it means that x is less or equal to this. So, but less than minus 2 is what? Less than minus 2 and 1/4. Yeah, so you can draw a number line there. So what is less than minus 2 and 1/4? I mean, if we come and then say x is less or equal to minus 9 out of 4, which means x is less or equal to minus 2, remainder 1 out of 4. And then now we can come to the number line and say, okay, number line of x, and then we have minus 2 and 1/4, we plot here. What are the numbers that are smaller here? Okay, because we know that if there's a negative number, 0 is one of the numbers. I'm not putting all the possible numbers here. I'm just jumping the numbers, just putting significant ones we want to put, but we must put them in the right order. So now, where this is minus 2 and 1/4, and then we can put minus what?
Minus 9.
Minus 3. Okay, yeah, it doesn't matter.
Okay.
Or whatever the number, because if it's minus 2 and 1/4 is minus 3. Okay, because this minus 2 and 1/4 is minus 2. 1/4 is 2.5. It's 0.25.
Yes.
So now if it's 0.25, then we have minus 2.25. Then it's minus 3. Then you can put minus 4. I'm just ordering the numbers. Minus 5.
Okay.
You put, you know, the numbers that, with the negative numbers, then a number that is like bigger, because if you like 2 and 1/4, 2 loaves of bread, 2 loaves of bread and 1/4.
And 1/4.
And then now you compare that with 3 loaves of bread. Which one has more bread? But between the one that is 2 loaves of bread and 1/4 and the one that has 3 loaves of bread. Okay. Obviously, the one with 3 loaves of bread has more bread. Okay, because it has full loaves. This one has
full loaves.
Full loaves, but this one is like 2 loaves and 1/4.
And 1/4.
Yeah. So what is then the implication of this? Okay, then we are then saying, okay, now if you have minus 3 here, but minus 3 in terms of numbers is smaller. When you put the negatives, then the sense changes, you know, because the minus 2 and 1/4 is bigger
than
negative 3, and negative 3 is bigger than negative 4. As much as 4 is bigger than 3 when they are positive, but once you put negatives, then it's, you know, the order changes. Okay, so now at this point, we are then, I'm mentioning these because want to check, and I was asking the question, and I'm still asking the same question. How do you know if your answer is correct? You know, can know if your answer is correct if you substitute into the original equation, and the substitution confirms the truth of the inequality and gives us a true result. But obviously, we don't want to, work like donkeys, but we want to work smart a little bit. So what do we do? Okay, we can take a number. Let x be negative 3 for argument's sake. You get the point. So we have minus 3 divided by 2, bigger equal to 3 minus 3 plus 1. Okay, what is 2 times minus 3?
It's gonna be 5.
Okay, never mind that.
You said 2.
Yeah, 2 times minus 3. I'm just teasing you, remember. I just tease you by asking because I need to know what you think, but also it's selfish of teachers to just go to class and say, hey, I must tell you everything, and you never say a word. With me now at university, because when I started learning these things myself, when I learned these things at university, I first obviously have been at Contact University, and with Contact Universities, the tendency is that the lecturer comes and talks and goes, you know, comes and stands at the front, talks and goes, and they do that. But in the end, then at some point when I had to start teaching, I realized that I had a tendency to lecture than to teach. But
Yes.
I quickly realized that it was not working. It was not working for my learners because whenever I could just stand in the class thinking that if I explain more from beginning to the
Yeah.
end, if I explain until I sweat and wipe my sweat and keep writing on the board more and more and more and more and more and more and more, I would think I'm teaching a lot and everybody's going to get 100. But I quickly realized that it's not working because those kids, even if you teach and then now you give a test on the things you have taught, the kids don't even remember.
Yeah.
They can't even remember anything, you know. They forget the things because I realized that, hey, what can I do now? Because the books are full, but the kids don't know the things in the books. They are full of notes. I gave a lot of the notes, but the kids do not even make sense of the things. I realized that I was supposed to give the work slowly. I was supposed to give a definition and interact with the learners, you know, and then give an example and explain it, and then give an exercise and they try and I engage with them. Then I saw that it was making a difference. I saw that now the best way to teach is not just to give, to talk. No, because the kids forget everything. Okay, and we humans who deal with, you know, I like that as well. So now 2 times minus 3 becomes a minus 6.
It's gonna, yes. You
Okay,
you
that's fine.
multiply 2 times 3 is
You multiply 2 times 3 and it's 6. But
then you add them to the negative.
Yes, you include the negative thing. So obviously now we need to remember that. Let's deal with the signs. Let's deal with the signs. What is negative times negative?
Yeah, negative plus negative is positive.
It's positive. Okay, I'm just teasing you with the signs. I'm just playing with the signs. I want us to remember the signs a little bit because they're coming here. Right, we have negative times positive, and that is negative. And then what about if you have positive times negative?
It's
positive.
positive.
Negative. Never mind.
Really?
Okay, never mind. So, okay, never mind. But what I'm saying is, if we're multiplying like opposite signs, if you're multiplying a pair of opposite signs, then it's a negative. Okay, but if the signs are the same, then it's a positive.
They're always positive.
Okay, for example, if you're multiplying a positive by another positive, it's a positive because the positive and positive are the same. Okay, negative, multiplying them, negative by negative, you get a positive. Positive, you get a positive. But if the signs are different, like negative times positive, then you get a negative. Because now a positive times a negative, they're different. The positive and the negative are different, and therefore you multiply them, you get a negative. Okay, I'm mentioning this on purpose. I'm mentioning this on what? On purpose. Okay, now, because now we are multiplying the 2. If then there's no sign in front of the 2, it means the 2 is positive.
Yes.
And then now we are multiplying a positive, because first we multiply the signs in the true sense of things. But yeah, we are most interested in the numbers. But okay, we multiply like positive times negative is what? It's negative.
It's
2 times 3, it's 6. And then we have minus 3. And then you divide by 2. You have this. You have 3. Minus 3 plus 1. What is minus 3 plus 1? Okay, now you need to remember this. Now, when dealing with minus 3 plus 1, okay, I'm just mentioning this and I'm pausing because I realize it's the best way to teach, to engage than to just talk, you know, because in the end, no one remembers a thing. And it becomes so painful when the pastor has preached for the whole 2 hours and no one even remembers the verse that was read. Okay, yeah. Minus 3 plus 1.
Can I try it?
Yes, please.
Minus 3 plus 1, it's gonna be your negative 4.
Okay, that's fine. What now?
You said
yes.
we're adding different
Okay, remember that it's the different signs. Yeah. Okay, so now
whenever there's no sign, it means it's a positive.
Yeah.
Am I right?
Okay, yeah.
If there's no sign, it's a positive.
If there's no sign, it's a positive.
Yes.
Yeah, because I'm dealing with the numbers in the brackets.
Yes.
I'm dealing with the numbers in the what? In
In
the
the bracket.
brackets. So dealing with the numbers in the brackets would be minus 3 plus 1. What would minus 3 plus 1 be? Okay, minus 3 plus 1 would be if you are adding two numbers, because you are adding negative 3 and 1.
Yes.
It's called
Yes.
addition. But if you're adding two
Alright.
numbers with opposite signs, one is negative, the 3 is negative, and the 1 is
Yes.
positive. You take the sign of the bigger number,
Which is the 3.
which is the 3. So the answer is going to be negative. You choose the
Negative
sign of the
4.
bigger number because the bigger number dominates.
Yes.
And then from the bigger number, you minus the smaller number. From the bigger number, you subtract the smaller number.
Okay.
So from the bigger number, which is 3, you subtract the smaller number, meaning 3 minus 1 will become a 2.
Negative 2. Yes.
And the answer therefore becomes negative 2.
Okay.
You get the point? Okay, we're playing around with the
So
sort of
it goes differently with them.
the
Signs,
multiplication.
the multiplication
It goes
and the
different with the
addition.
multiplication. Yeah, and multiplication and the addition
Yes.
are quite a little bit different. Okay,
Okay.
they are different indeed. Multiplication. So what are the binary operations that we learn? What are the binary operations? What are the binary operations? The binary operations are addition, subtraction, multiplication, division. But you see, this addition and subtraction go together.
Yes.
They're sort of subtraction is sort of the opposite of addition. You can think of it as the opposite of addition, and multiplication becomes the opposite of what? Of division.
Division.
So in other words, multiplication and division go together. What do we mean by they go together? Well, they normally share a lot of common properties in the way we apply them, and we're gonna see what that means. Okay, we saw that this addition, subtraction, addition are friends. These are called binary operation. What is a binary operation? Bi means 2. So if you speak about a binary operation, we say bi means 2, and therefore these operations are called binaries, binary operations, because now it's like 2 plus 3. They unite two numbers. They unite two entities. Bi means two numbers. So we add 2 at a time. Yes, they sort of bind two numbers. Okay, so right. So now we continue.
Okay.
Then what is minus 3? What is minus 6 minus 3? We think about this. What is minus 6 minus 3?
It's now we're minusing. Minus is the same thing as addition,
Okay,
right?
never
Same
mind.
rules. We're using the same rules as addition.
Yes, we're using the same rules as addition, but if the two numbers have the same sign, we just take that common sign. If they have the same sign, we take that common sign and then we add them up. So now we take the common sign and then we add, like 6 plus 3.
Add, yes.
And 6 plus 3 gives us a 9.
9.
Yes, it becomes negative 9 because if the two numbers, we are adding them up, we take the common sign. The answer becomes negative because they're both negative. And then we add them up. Because this is addition, there's no multiplication here. Okay, and then you divide by 2, and it's greater. Just playing with this, and then we shall come to the questions. Then what is 3 times negative 2? Now we are back at this is multiplication in the brackets. We're dealing with brackets and we're dealing with multiplication. And 3 is positive.
It is.
Okay, because there's no sign in front of the 3, so it's positive, right? And then now what is positive times negative?
Negative 6.
It's well done. It's negative 6. I'm glad. I'm glad that you gave the correct answer. So it's negative 6.
Yes. Okay.
We think about what this means. We think about what this means. What is the meaning of all this? What is the meaning of all this here? Right, so the meaning of all this would be, what is 9 divided by 2? Minus 9 divided by 2. Okay, so minus 9 divided by 2, 2 goes how many times into 9? It goes 4 times.
4 times, yes.
Remainder 1 out of 2.
Mm-hmm.
Okay, so it's like minus 4 and 1/2. It's a mixed fraction, this. Minus 4 and 1/2
Yes.
is a mixed fraction. So minus 4 and 1/2 is greater or equal to minus 6. Now, minus the 1/2 is like a 0.5, you know?
Yes.
It's a 0.5. So why is 1/2 0.5? Because we divide this and say 2 goes how many times into 1. And then we say 2 does not go into 1
Right.
because
Yes.
1 is smaller.
Yes.
Okay, because 2 does not go into 1,
Okay.
then we include a 0 there. So that, but first we say 2 goes how many times, it doesn't go. And then we have
Yes.
0 points. Okay, we use a decimal comma, very awkward though in the country. And we need to change these things. Because in America and Britain, they use a decimal point, but we use a comma for decimals. Anyhow,
Okay.
right. We then say 2 goes how many times into 1? 0 times. We put a 0 comma and then we put a 0 there. 2 goes how many times into 10? 5 times.
Okay.
5 times.
So with every number, you add a 0 if it's smaller.
Yes, if it doesn't go, if the division is not
Okay.
possible. If you're dividing a smaller number by a bigger number, you add a 0. Right, you can continue adding as many zeros as possible. Okay, but now that is why the 1/2 is 0,5. So that now 1/2 becomes 0,5, but with the 4, it becomes like 4,5. We compare which is bigger. Is this true in mathematics? Is minus 4,5 greater or equal to minus 6? Is it greater? Minus 4,5. Is it greater? Yes, it is greater.
It's
It is
greater.
greater. Right. I'm happy that you're able to order the numbers. So it's greater. So in other words, this inequality is true. This is an inequality. So this is true. Okay. We were doing this because I wanted us to check if the answer we got, because we got an answer, but I wanted us to check if the answer we got was indeed correct. You know?
Yes.
We got the answer which was x is less or equal to minus 9/4. You get it? Okay, but now, yeah. And then we decided, okay, this answer we got, but yeah, is it correct? We substitute to check if it's correct, and if an answer is correct, we substitute into the original inequality or into the original equation and check if it makes it true. With the inequality, then the result you must get must be correct mathematically. And in this case, we have minus 4,5, minus 4.5, which is minus 4,5, is greater or equal to minus 6. Okay, so that's fine. So because it's greater, we're good. We're good. Okay, let's move on to the next thing. We spent a bit more time on the inequality here. But I feel that we're inspired. We are motivated. Yes, I'm glad. We are motivated to practice more. Right, and then to give more examples. I'm going to give more examples on some of this. More examples. Like, what are the examples? Like minus 5 plus 7. Okay, and then like 10 minus 13.
Yes.
Minus 2 minus 4. And then I'm just giving these things. I'm just generating them off the top of my head. But I want us to discuss this as we're going to move on. And then now, yeah, okay, we can mix them up. Like minus 2 times 4 is equal to what? Minus 3 times minus 2. Minus 7 times minus 3. Or times 3. Okay, yeah. Let's say 7 times minus 3.
Okay.
Okay, and then, yeah. It's awkward to write like this. Normally put some parentheses like that. Okay, then you put some parentheses like that so that the signs do not look nasty. Okay, right. I want us to practice this a little bit.
Okay.
Okay, yeah, let's practice this a little bit. Okay, just basic addition. This is not complicated. And then now we can look at hard. Yeah, it's a little bit hard. Minus 4.5 can be written. It's called a mixed fraction. It's called a mixed fraction. But this mixed fraction, can it be written as a common fraction? Can you convert these to a common? What would a common fraction be? Okay, by a common fraction here, I mean proper fraction. What is a proper fraction? Or improper fraction? Yeah. What is an improper fraction? Okay, we have a chance to dip into both 1501, 1502. Some of these basic things.
Yes.
Oh, yeah. So that we have minus 5 plus 7. What is minus 5 plus 7? So to deal with minus 5 plus 7,
yes,
what we
using the
do?
rules,
Yeah.
you said we check on first which is the bigger number,
Which is the bigger
and
number?
then
Well done.
it's 7. And
It's
then
7.
we
So
use
the
the
answer is going to
sign
be
of the
positive.
bigger number.
Yes, and then we
Yes,
take the sign of
it's
the
gonna
bigger
be,
number. Yes.
yes, we take the sign of the bigger number,
Yes.
and then yes, now we're adding, we're not
We're adding.
minusing.
Yes, we're
Yes,
adding.
so
We're not
we're gonna
minusing.
say
Yes.
7. Yes, we're gonna say 7 plus -5.
Yes.
Am I right?
Yes.
And then
Okay.
you
Okay.
get
Okay.
your
Yeah.
answer.
Definitely. I'm happy that you're on point. You're on point. So what we
Yes.
do, because that's why I'm just giving this. We're gonna play around with this, and then we shall continue with the rest of this.
Yes.
But we are
Yes.
then saying, if you, this is called, obviously you are adding. Yes, this is all
Yes.
addition. You are adding, but now the numbers have like opposite signs.
Yes.
One is negative, and the other one is what? Is positive.
It's positive.
The sign of the number is always written on the left of the number. It's always written
Yes.
first. It's always written first.
Mhm.
Like the 5,
Mhm.
this is 5, but its sign is negative because we wrote the negative
Mhm.
first. So if you're adding them up, what do? You take the sign of the bigger number,
Yes.
which is 7.
Mhm.
And from the bigger number, you subtract the smaller number, always. So you
Always.
take the
Okay.
sign of the bigger number, and from the bigger number, you subtract the what? The
The
smaller
smaller
number.
number.
So now, the sign of the bigger number is plus. And then we
Yes.
then say, from the bigger number, which is 7, you subtract the smaller number, which is what? Which is 5. So we then
5.
7. So it doesn't then matter that the signs do not matter anymore. To add these,
Anymore.
we just say which number is bigger. 7. So the
All
answer is
right.
going to be
Yes.
plus. And then from the bigger number, you subtract the smaller one. Like
Mhm.
7 minus 5. What do we
2.
then get? We get a 2.
Yes.
So the answer is plus 2,
Okay.
you know? And then
Yes.
we also continue like that. And but we use some tools also. I mean, it's not a question of just saying, we're doing things that way only. I'm gonna use a
Yes.
calculator. I know that this is too basic, doesn't need a calculator, but I'm gonna launch a calculator. So we have a chance to engage, Let's see this. I'm gonna launch a calculator. Here's the calculator. Look at this. See the calculator, yeah, it's here. Now, you would say this one. So the calculator can do like -5 plus 7. Okay, -5 plus 7, the calculator gives a 2, which is indeed a plus 2.
Yes.
Okay, so yours is a tool we use. It's a tool we use, this calculator. Okay, let us practice now and do the next one. Okay, the next one, for instance, is -10 rather 10 minus 13. What answer is it's going to be this? Okay, I'm just teasing you with some of these, but right, what answer am I going to have here if we say 10 minus 13? So
It's
what do we
gonna be
do?
a -3.
It's going to be a -3. Why?
Yes.
Okay.
Because the signs both on both numbers, the sign are equal.
Yes.
It's a positive, yes. You adding your positive and you're minusing the another positive 13.
Yeah, so the 10 is positive and the 13 is
Yes.
negative. But now you
Yes.
take the sign of the bigger number.
Yes.
And the bigger number is 13.
Yes.
So you take the sign of the
Then you
bigger number,
minus
which is
the
negative.
10.
Then you minus the 10. Then you say 13 minus 10. And then you say you get 3. And
Yes.
indeed, that is correct. Okay, we're just practicing with some of these to just remember some of the basics. Because you must build up. And that is what showed me teaching is. Teaching is
Okay.
the question of just sometimes shouting from beginning to end. Sometimes you can go to class and just teach only one problem and do one question and discuss it with everybody. But it helps to then say you give some exercises. The exercises should not just be done by the teacher, because sometimes we think that we've learned so much and we feel energetic to just keep teaching, but we are damaging. If you just keep giving, the kids end up not knowing what to do themselves when they're alone, you know. So now you have 10 minus 13. Right. So I'm using this calculator just to compare our results, but yeah, 10 minus 13, I know it's basic, and the answer is actually minus 3 then. And we're able to see the minus 3. Okay. Now, because with the 10 minus 13, we said that you choose the sign of the what? Of the bigger number. And the bigger number is what?
Number
Is 13.
is
And its
13.
sign is negative. And then from
Yes.
the bigger number, you minus or you subtract the smaller number, so that we have 13 minus 10, and
Yes.
13 minus 10 is a 3.
Yes.
Next. Minus 2 minus 4. Minus 2
two
minus
negative.
4. Yeah.
Your two negative are your, it's called to your negative.
Yes.
So
yeah. So yeah. So now
I'm gonna.
what do we do here? If we are dealing with the minus 2 minus 4, I mean, how do we add this? How do we get the answer to this? Or how do you subtract it? You start, yeah, but it's all addition. So subtraction is referred to as, yeah, it's a form of addition of the negative numbers. But now, yeah, what do we do? Minus 2 minus 4. I just created these numbers.
It's gonna be positive 6.
Okay, that's a good question. So because we're adding, if the signs are the same, you take the common sign.
It's equals to your positive sign. Your negative sign, two negative sign, is equal to positive sign. I'm not sure if I'm clear.
Well done. If we are multiplying them,
Yes.
like if you say negative 2 times negative 4, we said that indeed negative times negative is a plus, and then 2 by 4 is 8.
Yes.
Okay, right. But if you're adding them up,
it's gonna be your.
You take the sign. You take the common sign. You take the common sign, because we're not like multiplying. We're not multiplying.
Yes.
But we are like adding up. Yeah. So there's no multiplication. So yeah, if it's negative 2, negative 4, we take the sign of the common sign, because they have the same sign. I mean, it's negative, negative. And 2 is negative and 4 is negative. So the answer is gonna take the common sign, because it's the negative sign that is common. And then now you add 2 to 4.
6.
And you get a 6. Well done.
Yeah.
And therefore the answer is going to be minus 6. You'll forgive me because I'm trying to, I thought that it would be wonderful to just play around with these basics, and now you.
No, it's fine. It's fine. I don't have a problem.
Yes. Okay. Right. So now, we have negative 6 there, and also, always when you're learning these things, we can give like hundreds of these things. Yeah. Hundreds of this, and like play around with them until we avoid, human error that can arise. Here's a calculator, and we have minus 2 minus 4. Minus 2 minus 4. Okay, we have minus 2 minus 4. I'm using the calculator to confirm our result. And minus 2 minus 4 is indeed a minus 6. It's a minus 6.
Yes.
Okay, we're good. So it's a minus 6.
Yeah, we're good.
We're good. Next. Okay, if you have minus 2 times 4, now we are multiplying. So the rules are like a little bit different, because before it was like addition, this minus that. We're not multiplying anything. But now we are multiplying now. Like if you have minus 2 times 4, now we're multiplying and the rules are different. So the rules are, what are the rules? Like now we are multiplying, we have negative times negative, because the signs are the same. If you multiply negative and negative, the signs are the same and you get a plus. Positive, positive, you get a plus. If you have negative together with positive, you have negative. Positive, negative, you have negative.
No.
Okay. So, okay, we're good.
It's gonna be our sign is negative and positive.
Yes,
So
negative and
we
positive.
got yes.
Yes.
So we're gonna get a negative sign.
We got a negative sign. We got a negative sign. Shall get a negative sign. We're good. Shall get a
Yes.
negative sign. And then now, because it's negative for the 2 and positive for the 4.
Yes.
The 4 has no
Mm.
sign, so it has a plus there. So it's negative times
Yes.
positive, and we get a negative. Then what is 2 times 4?
Yes.
It's exactly 8.
It's
Okay,
8.
good.
Yes.
Now, what about if we have negative 3 times negative 2? Negative 3 times negative 2. Okay, now negative 3 times negative 2. Now
Okay.
you first multiply
We
the
check
signs.
the signs again. Yes.
Yes.
We check the signs again.
Yes. Well done.
You said the rules said if it's your negative and negative, the signs are negative and negative.
Yes.
You put it. It's gonna be a positive.
It's gonna be a positive because we're multiplying.
And then
because we're multiplying, it's gonna be a
because
positive.
we multiplying is.
Yes.
Then you multiply your numbers, which is 3 multiplied by 2.
Which
It's
gives us
gonna
a
be
6. Well done.
Yes.
So the 6 is correct. And then
Mhm.
we shall get to we shall get to the things that sometimes these guys post on the Facebook pages. Sometimes you see some basic math like this where they just add
Yes.
numbers. And now
Mm-mm.
it's not even advanced math that you're seeing, but now you see it actually sparks some debate in terms of their operations and things. Yeah, it's
Yes.
okay. I'm gonna share some of these things I've seen on Facebook and Instagram, and people just practicing and engaging the kids. But yeah, you'll be like, okay, but what's the answer? Some of them are ambiguous, and take a look. Okay, what about 7
Okay.
times minus 3? 7 times minus 3 is what? Just wondering.
It's negative because we have 2 different signs. We have a
Well done.
positive
It's
sign on
negative.
the 7.
Yes.
Yes.
Positive sign the
And
7 is
then
negative on the 3. Okay, so yeah, it's negative.
negative
And then what we got?
21. Negative 21
Negative 21. Negative 21.
is.
Negative 21. Okay, negative 21.
Mhm.
Okay, now we're good. We're good.
Is.
Okay, what about minus 4 and 1/2? I was saying minus 4 and 1/2 is a mixed fraction. Okay, it's
Yes.
called a mixed fraction. But can we convert it and write it as a proper fraction or an improper fraction? Can you write this minus 4 and 1/2 as a common fraction? How do we convert? How do we convert a mixed fraction to a common fraction? How? What do we do? You get my question?
Mm.
Okay, because now if you have minus 4, okay, giving the same thing there, okay, right, maybe I give minus 7 and 1 out of 3. How do this is a mixed fraction. How do we write it?
Yes.
Because now it's mixed. It's minus 7, then 1 over 3. The 1 over 3 is small.
It's
How
small.
can
It
you
is.
how can you
Because
write it? Yes, how can you write it as a number over a number like this, so that it's not mixed like this? Because you see, the somebody get like, why are you writing the numbers like this? Why don't you write this fraction as a number over a number? But if we want to change it and write it as a number over a number, what do we do? Okay, this is what I'm gonna get to, just to catch up on this. So if there's a sign there, it remains. It remains. But the 4 times, then you multiply this with this. You multiply this with this. 4 times 2. 4 times 2 gives you 8. Okay.
I saw the 8 years.
That's fine. 4 times
Yes.
2, never mind. Yeah. 4 times 2 gives you 8 plus 1.
Yeah. It's 9.
It's 9 out of 2. Which means that minus 4.5 is minus 9 out of 2. It's minus 9 out of 2. How do we know? we multiply like this.
Yes. Yes.
4 times 2, and then you get an 8 plus 1, it gives us a 9 out of 2. Okay, now,
and then in this situation,
yes,
which rules do we use? We use the multiplication rule.
we use multiplication and addition. Yeah, we use multiplication and addition. Now, for example, if we have -7 and 1/3.
Yes.
Okay, now sometimes it's popular, it's common to deal with these mixed fractions. Sometimes
Yes.
it's more practical, because if somebody has 2 loaves of bread and a quarter, you know, you can say you have 2 and a quarter, 2 and 1/4. But 2 loaves of bread and a quarter of bread. Then we then say, can you convert it? It makes sense to write it as a mixed fraction, but can we convert it into a common fraction that maybe is nicer and more common than mixing things like this? Okay, so now, yes, we can. But what would 2 and 1/4 be is a big fraction that is like numerator and denominator. What we do?
We multiply the same procedure that you did. You multiply
Yes.
4.
Yes,
2 by 4.
yes.
Yes.
And you get 8.
You get the answer. Yes.
Yes.
Then you multiply your 2 times 1.
Yes.
Then you get your
Okay, yeah.
fraction.
So we say 2 times 4.
Proper.
We
Yes.
say 2 times 4. 2 times 4 gives us 8.
8 is
Plus 1. Plus 1. And that becomes a 9 out of 4.
9.
9 out of 4. So which means that 2 and 1/4 is the same as 9 out of 4.
Yes.
What about if we say we have -7 and 1/3? Okay, this makes sense even when we're doing measurements. Sometimes we can be saying, oh, we have 7 centimeters and 1/3 of a centimeter. But how do we write it as what? How do we write it as a nicer fraction that is common? Because now somebody can be like, hey, these kinds of numbers, they're mixed this. I'm sure we're calling these mixed fractions because people looked at this and they were like, these things are mixed. How do you even write this 7, 1/3? What's happening here? You know, it's like numbers are mixed. Yes, they're mixed, and hence we call them what? Mixed fractions. And this concept of mixed fractions is correct in the English language. But now we then say -7 1/3. How do you write it as what? As a fraction that is common fraction.
Okay.
Yes, or yeah, you can call it proper. Yeah, so what do we do here? What do we do here? So you think about it.
We're using the same procedure, but we're gonna have to look at the sign first, right?
Yes, you need to look at the sign first, because if there is a negative there, the sign is always the same.
It's gonna be negative. Yes.
Yeah, it's always carried forward. And then what do you then do now?
You multiply 7 by 3.
You multiply then 7 by 3, right? And then 7 times 3. Just easy. I know we know that.
21.
21. Yes. And then you say
then
21 plus
1
plus this 1.
Yes.
Which is what? Which is 22.
Yes.
Out of 3.
Then it's gonna be out of 3 years.
Yeah, and then now this is the answer. Okay, this is 22 out of 3. But if we give -22 out of 3 to a student and say write it as a mixed fraction, because we can do these things in reverse. Okay, we can, yeah. -22 out of 3. This one. Can we break it down into a mixed fraction? How? How? How would
Are
you
you
break?
not going to divide the 3 to 22 by 3?
Yes.
Then you get your 7.
Yes. Yes, you 7. We say 3 goes how many times into 22? Okay, the sign is always there. 3 goes how many times into 22? It goes 7 times, because 3 divides 21. It goes into 21. Yes. 7 times. It goes into 21 7 times.
Yes.
And then the remainder is 1 out of?
1 over
1 out of this number. Okay, so that is what we have.
Okay.
1 out of that number. Okay, yeah, we're just practicing some of the basics. Let us move on now to the following. So the question becomes, can you illustrate the solution on the number line? Okay, remember that the answer we got here was x less or equal to minus 9 out of 4, and we obviously got that number. But how do we sketch it on the number line? What do we do? I want us to talk a little bit. Never mind that. Because I think that it works. Because it works with me also when I'm learning.
Yes.
I feel that if I engage more when learning,
Okay,
I
let me
more.
just try to explain it because I can't draw it to you. We're
Yes,
gonna draw
yes.
a number line.
We're
We're
going
gonna
to
draw
draw
a
a
line.
horizontal line. We're going to draw a horizontal line
Yes.
with the number line. And we're going to
And then
plot the number here. And then what do we do
then
after this?
we take. Where's the zero? There's no zero. Are we
Okay,
not
that's
supposed to
fine.
put the
That's
zero?
fine. Yes, okay, that's fine. So because this one is a negative number, 0 is always
Yes.
the right of the negative numbers. And then we can put some positive numbers there,
Yes.
But I just decided to just put one number. But obviously, you see, we can put, but for us to put many numbers, we need to be, because it's minus 9 out of 4, so we need to sort of focus how many times into 9?
Yes.
2 times, so remainder 1 out of 4. So, okay. Right, so, okay, you have like the minus 2 and 1/4. Okay, you can put some numbers, because if you put minus 2 and 1/4, then you can sort of know the number is like a minus 2, but it has like a quarter, a quarter
only.
Yeah, and then now okay, it's a negative number, then you can put so you can put some other numbers, like if you put okay, you can put, if in minus 2, you can put minus 1, and then you can put, it doesn't matter, Okay, but obviously we're not following a common step here, because this one has fraction attached to it. It has a quarter attached to it. But then what do we do? And that sort of answers the question. Okay, you can do this. Because this is minus 2 1/4, then you can put minus 3 here. You can put minus 4 there. But the question is, what do we do? What do we do?
Aren't we gonna do that point, that dot and the line? I don't know what they call it.
Okay, there's a dot and the line. Well done.
Yes.
Thank you so much for describing it. Okay, yeah.
Yes.
Okay, yeah. Anyway, sometimes obviously it's tricky to say what that is called. I think a dot would be more appropriate. But sometimes we say there's an empty circle and then there's a full circle.
Okay.
Okay, there's an empty circle and then there's a full circle. It's like, yeah. So you then say, yeah, and then you, x is less, so you go to the left.
Yes.
You go to the left. Okay, now, okay, that is what we are seeing. Now, let us continue with these things. But what do we do with this? What do we do with this? Okay, we have illustrated the solution on the number line. This is what we're supposed to do. We have done, because we're supposed to illustrate the solution on the number line. That is what we do. So it's something that we've done, and we're excited with it, and we move forward to the next thing. What do we do next? We do 2.3.1. Right.
Yes.
We are having a laid-back discussion, and we are just having some dialogue on these things to see exactly how we can learn them best, but also how we can sort of internalize the learning. And now learning happens when normally we talk to each other than just to dictate to each other, because sometimes the kids end up even hating the teacher. Sometimes if the learners are there in the class and they don't understand what is happening, they end up hating the teacher. But the teacher
hating the subject.
Yes, hating the subject. They hate the subject. There are times when I was in school, if the teacher comes, you would feel as if, my goodness, this guy should not come. Okay, this guy should not come because he's boring. I don't know, something like that. So, or he's not the kind of guy whose lesson you enjoy. Because maybe the lesson is, Maybe normally it's boring if you can't relate to it, you know, and then be like, this one, it's what's the point of coming to the class? But the guy is doing his job. And
Yes.
the subject might be difficult, maybe, I don't know. But yeah, is there a difficult subject after all? Perhaps not. All subjects are easier if we do them the right way, I believe. But
Yes.
yeah, okay, let's do this one. Why don't 2.3.1?
Mhm.
We want us to have a dialogue about these things than just writing the answer.
All
What do
right.
we do now? Meeting a question like this. I'm looking at this and there are billion ways, like billion ways. But what do we do if you have a question like this? We need to solve for x. That is what we need to do. X plus 1 all squared equals x plus 1 in brackets times 2x plus 3. Okay, what is the first thing? I know there are too many first things here. I'm looking at these, I'm like, billion ways, because I've learned this and doing this, doing that, doing, you know, there are many ways to do this. But maybe what would a common person do? A common person, a layman. You say, what would a layman do in a situation like this?
Look,
Right.
look at the bracket. Start with the
You
bracket.
you start with the brackets. Bodmers.
Yes.
Oh yeah,
Yes.
Bodmers. Okay, right. Because we're just discussing these. You start with the brackets. It's Bodmers, and with
Yes.
Bodmers now you square. So you say x squared,
Yes.
and then x times 1 times 2. X times 1 times 2 brings what?
X,
Okay, we're just talking.
X,
There's no hurry.
X times 1
Normally
times
we
2.
say x times 1 times 2. Yeah. Normally
Yes.
multiply this, with that. With their signs, but it's positive, all these things. Okay, x is not positive because
Yes.
it's a variable,
It,
but
yes.
associated with it, there's no sign we can see, so we can imagine a plus in front, but it can still be negative because it's a variable. Variables can either be negative or positive or neither, because the variables can be 0 as well. So we say x times 1 times 2. What is x times 1 times 2? It's 2x. It's 2x.
So how do we determine if it doesn't have a positive sign or a negative sign? Or we just decide that it's our 0, the x is the 0 because it's a variable.
Yes, so in other words, the x can be 0, but
Yes.
we cannot know yet until we get the value of x at the end. So
Okay.
because of that, the x is unknown. You see, strictly speaking, we can ask, is the x one is positive, 3 is positive? We are sure about this. But
Yes.
x is a variable, so it will depend on the answer we get. Because if ever x becomes 0 in the end, I'm not saying it's going to be 0, but if ever it becomes
Yeah.
0, then having read this x as a positive x becomes incorrect. Because we would have read,
Okay.
if somebody says the x is positive and x becomes 0 in the end, that would mean 0 is positive. What is the sign of 0? I mean, is 0 positive or negative? You know?
Negative. It,
Yeah, I mean,
it, it,
if somebody writes 0, is it positive or negative? This, you know, I'm just teasing you with
it's,
this, okay?
doesn't,
But
it's just a number. It's a
it's
0. It's
it's it's
nothing.
neutral, okay? 0 is
Yes.
neutral, okay? 0 is neutral because 2 is positive. -3, this one is negative,
Negative. Yes.
okay? But 2 is positive. But 0 is what? 0 is neutral.
Neutral.
Well, in principle, it is neither negative nor positive. Okay.
Mm.
So, right. So 0 itself is neither
Negative or positive.
negative nor positive. All right. So we have 1, we square the 1. If we square 1, what do we get? We like 1 squared. You can write 1
Yes.
squared, but 1 squared we know is 1. It's like 1 times 1.
Mm.
So we can just write 1, but you can write 1 squared still. But yeah, but you see, the thing is that 1 squared, we know very well that 1 squared is 1. Is 1 times 1.
Yes.
Next, what do we do?
Yes.
Okay, we dealt with the left. We dealt with the left. The left was
Yes.
called is of the form a perfect. perfect what? It's called a perfect square. Why? Because a perfect square in mathematics is like, it's like if you have, for example, 2 squared. Remind that? Okay.
Yes.
If you have like 2 squared, okay, you have 2 squared like 3 squared. It's called a perfect square, this. It's called a perfect square. And hence, in mathematics, we then proceed to say 9 is a perfect square. We proceed to say 9 is a perfect square. Why is 9 a perfect square? Why? Because 9 is what? It's 3 squared.
Yes.
So because 9 is 3 squared, then it is what? It is a perfect square.
Perfect square.
All right, we continue. Okay, we're good. So we continue. We continue. All right, so yeah, we're done with the left. Left, it's this. Then we deal with the right. What do we do now with these things? X plus 1 in brackets times 2x plus 3 in brackets. What do we do? What do we do with these things?
With both, should we do them both at the same time? It's gonna
Doesn't matter, but yeah, anything that is correct. Yeah.
Can I try?
Yes, please try, because that's why we are here.
X1 multiply by 2x plus 3.
Yes. Yes, x plus 1.
Yes.
X plus 1 multiplied by 2x plus 3.
Yes.
What answer do we get? Yeah?
It's 3x.
Okay, we multiply this with that. You multiply this with this. So we use what you call the FOIL method.
Okay.
And the F stands for the first. The O stands for what you call the outers. The I stands for represents inners. And the L represents what you call the last.
No.
So let's start. So you're going to start with the first. First is this with this. So you have the first. Then we have the outers, because this and that are like outsides, these things. We call them outers. And then we come to this and that. These ones, we call them inners, because they're like inside, you know. And then now, you then multiply the last one. So you multiply this with this, and then you multiply the last. This is the last, like that. Okay. With this, then we multiply the first, which is this and that. And then we deal with the outers, this and that. The inners, this and that. And then the last. So we have x and 2x. What is x times 2x?
3x. Not too sure.
Okay, never mind. X times x is equal to what? It's x squared. Okay, so x times x, how do we know?
2x.
Okay, right. Okay, yes. What is x plus x? X plus x would be 2x.
Oh, multiplication is a square.
Yes, multiplication then becomes a square.
Okay.
Okay.
So now we're multiplying because there are brackets. So it's gonna be x multiplied by x because we have brackets.
Yes, because of brackets. It's gonna be like x times x with brackets. And then x times x becomes x squared.
Okay.
What is x squared times x? Just teasing. What about if we multiply? Because we can multiply anything. Like we can multiply like x squared times x. X squared times x becomes x cubed. Okay, you add the powers. 2 plus 1 becomes 3. So x times 2x becomes 2x squared.
So whenever there's no, with this x squared times x, whenever there's no number, it's always a 1.
Yes,
Let's say, for
whenever
example, you
whenever
give
there is
me,
no number, yeah, we can imagine a one. Either way, obviously even the exponent, call that the exponent of the x.
yes,
So you see the x is if you just write x and there's like no visible number
yes,
that is an exponent, it means it's one. And then I take the
1,
two
1,
base
yes,
and
it's
add
1.
1 plus 1. 1 plus 1 is what? It's 2.
It's 2, yes.
So that is x
Okay.
squared. Okay. So we're good.
Alright. Mhm.
Okay. So we multiply x times 2x, we get what? 2x squared. X times x
Mhm.
squared. Then we have x times 3. Because this was like the first. Then you deal with the outers, the x and the 3.
Yes,
What is x times 3? Is 3x.
3x,
Then you deal with the inners. Inners. These ones are called inners because they're like inside this. 1 times 2x.
yes,
1 times 2x gives 2x. Then we have the last.
mm,
1 times 3, 3.
3.
Okay, so
Okay.
yeah.
Then we add them together now.
Then we add everything together. We collect like terms and the likes, We can add them
Okay.
together even if we add these ones. Okay, we can still write x squared plus 2x plus 1, and this is equal to 2x squared, which is this 2x squared. 2x plus, right, 3x plus 2x. It's 5x
It's
plus
5x
3.
plus
Okay, we're
3.
good. Right, so now we continue, then we can write here. What do we do now? What do we do now? Okay,
We
so
illustrate it on the number line.
yes, that's written on the number line. So we have 2x squared. Okay, yeah, before that's written on the number line. We collect like
Okay.
terms. So you have the 2x squared, we move this x squared to the other side, becomes negative.
All right.
5x and we subtract 2x. 3 minus 1 equals 0. Okay, let's continue.
Okay. Like you said earlier before that, what if it's gonna be 0 at the end?
Yes, okay. This thing just
Eh,
moved.
Okay.
Good. Okay, what if it becomes 0 in the end?
Mhm.
Yes. What if it becomes 0 in the end? In which case, therefore, 0 is neither positive or negative. So meaning x in general, we can't say it's positive or negative until we know
Mhm.
the answer, and the answer
Yes.
can only be known if we work out everything and work out through all the steps. Okay, now what is 2x squared minus x squared? We have 2 apples minus 1 apple, 2 apples minus 1 apple. What answer do we get? I just need to engage a little bit more so that these
A
things can.
negative. A negative.
Yeah, if you have 2x squared minus x squared, what do we get?
It's 1x squared. It's 1
It's
squared.
1x squared. Well done. 1x squared. Like 2
Yes.
apples minus 1 apple is what like 1x
Yes.
squared, but yeah, it's 1x squared. You can just write x squared like that.
Yeah.
Okay, next. We have some
And
other things
then
like 5x minus 2x. We have 5x minus 2x.
3x.
What do we achieve?
No, sorry. Wait. You
Yeah.
check the signs.
Yes, you
Check
check the
the
signs. You check the signs.
yes,
And then if you check the signs, then you check the sign of sort of the bigger number.
the bigger
And take
number.
the sign of the bigger coefficient. We could call this the coefficients. Sign of the big
Yes.
coefficient because each one has x in it. And the x is
Yes.
problematic because we don't know its sign yet until we know the final answer to the problem. And then you can say, okay, the x we're dealing with was actually a positive x or a negative x because we know the answer now in the end. But we're asking then the question, what is 5x minus 2x?
7.
Okay, never mind. So obviously we need to choose
Yes.
the bigger number. Never mind. We need to choose the bigger number, which is bigger between 5 and
It is
2.
5.
5
Yes.
is bigger. Okay, we ignore the signs when you want to decide which one is bigger. We ignore the signs. And
We
then
ignore the
which one
sign.
is bigger? Which one is
It's
bigger?
5.
It's 5. And then from the bigger number, you subtract the smaller number. So you take the sign of the bigger number. What is the sign of the bigger number? It's plus.
It's positive.
And then from the bigger
Yes.
number, subtract the smaller number. What is 5x minus 2x?
It's 3.
3x. Well done.
It's
3x. What is 3 minus 1?
it's
What is 3
positive
minus
1.
1?
It's 2.
It's a 2.
Yes.
It's a 2.
It's a positive 2.
It's a positive 2. Well done. It's a positive 2 because
Yes.
I like the fact that you're saying positive 2 because now we're choosing the sign of the bigger number, which is
Bigger
positive.
number, yes.
Positive 3. And then from the bigger number, subtract a small number. Okay?
And
Good.
again, with this one, the reason I kept quiet, we said we
Yes.
take the sign of the bigger number.
Yes.
And it also looks like a positive 3 and a positive 1.
Yes. You would obviously imagine it that way. You would
Yes.
imagine it that way. So obviously,
So what's gonna happen in this case if it's a positive 2 and a positive 2, like it's 2 minus 2?
okay, like
Or
you're saying 2 minus 2 like this.
yeah, yes.
Okay, that's a good
Then
question. So what is the answer to
yes.
2 minus 2? Right, let's
Oh,
discuss that. What is the answer to 2 minus 2? So obviously at this point, you say you choose the sign of the
it's a
number.
0.
Yes,
It's a
so it's
0.
0. Yeah, but you see,
And
I mean, it's exciting that you mentioned that because we are saying
yes,
that if you're adding the numbers, you choose the sign of the bigger number.
yes. Now the numbers are equal and the signs are the same because it's positive and positive.
Yes, so now there's no bigger number between the two. So now
And then
between the two numbers, so the numbers are equal. So in other words, the sign there's not what sign do we choose? Then 2 minus 2 becomes 0, obviously, and 0 is neither negative nor positive.
so so either way, even if the signs are different, it's negative and positive, it's still gonna remain a 0. We're not gonna
Yes,
use a
that's
negative on this.
correct.
Okay.
Yes, definitely. But I mean,
Okay.
there's nothing wrong with writing negative 0 or positive 0.
Yes.
There's nothing wrong with that.
Okay.
Nothing wrong with this. Okay,
Yes.
so there's nothing wrong with not writing negative 0, positive 0. There's just nothing wrong.
Okay.
We continue. Okay,
Yes.
let's continue and do the next thing. Okay, remember, we're not done solving this question, and we find ourselves digressing and mentioning this and that, but yeah, let us solve. Let us solve. Okay, to solve for x, there are a couple of ways to do this, and the best way to do this is the British factorization method. It has made waves in our schooling system ever since the times of apartheid. Factorization in South Africa wasn't done very well at school level. It is now in the CAPS curriculum that I've seen the grade 8 learners in all the schools across the country. You know, I deal with learners from the Eastern Cape, learners from KZN, learners from
Yes.
Gauteng, and so on and so forth. But you see, with the learners I see, they send projects, and the projects about factorization. And now they give them x squared plus 3x plus 2. Maybe not exactly this, but some quadratic, and they ask the kids to factorize this. But they take them through, they give them as a project, and it takes like a series of steps to do this. But
Yes.
what do we do? The best way to factorize this, because we need to solve for x, and the only way to solve for x is to factorize. Or perhaps one way to solve for x is to factorize. There are many ways to solve for x because a person can still solve for x without factorizing. Another way of solving for x, if you don't know what the value of x is to perform substitution and by trial and error. You know, you can do trial and error and then you put in different numbers here. And you put in different numbers and then you're able to guess the correct one. You can, yeah.
Okay.
You can guess. You can like, okay, what about if x is 0? You put 0 here. X be 0. You try. And then if it's gonna be 0, if 0 is correct, then it's gonna make this true. Otherwise, not. Okay. So
Can
yeah.
you give me one moment?
All
My
right.
dog is making me. Just one moment.
Okay, that's fine.
Okay. Sorry.
Okay. Yeah, that's fine. Okay, we're getting to talk about these things, which I feel is more effective. It's more effective because sometimes you can yeah, because I can hear that is barking there. The dog is barking there. I know.
Yeah,
I live with dogs. Normally
there are
when they're
people. I
yes.
think it's not gonna stop because there are people by the street.
Oh, maybe that's the
So
reason. It's people they see the
yes,
He's engaging with the people. I love dogs. I love dogs, but you see, at home we're dogs. Yay, but now they're
Yes.
problematic. Until we're to get rid of the dogs, because
Yes.
they had a habit. You know,
Yes.
they tasted chicken. Because at home we have we actually have dogs and chickens. So
Yes.
they tasted chickens. One dog killed a
They started
chicken.
eating chickens.
Then they started eating chickens. Every day you could
Yes.
find the chicken eating. Another day chicken
Yes.
eating. And then you're like, wow, we can't go on like this. You get the point. We
But I
can't go.
think
Uh-huh.
it's because of the breed of the dog.
Yeah, I think
Remember, we have
right.
the
Yes.
hunting one, yeah, the one that we use back at home for hunting.
Yes.
So if it's one of those kind, it's gonna eat chickens
Yes.
until
But
you train it
yeah,
not to.
of course. Because now we're like, yeah,
Mm.
we need to get rid of these dogs. We can't be losing chickens like
Mhm.
this because the
Yes,
chickens roam free in the village. They roam free.
yes.
But now,
Mm.
if you have the dogs, then because they just eat in the wild and trees, in the yard, the chickens roam free. But now,
Yes,
then with this, then it becomes so problematic, and in the end, yeah, we had to deal with the dogs then. Okay, all right. Now we
yes,
have this. We have this. Now we have x squared. I was saying that what we do to factorize this, you have x squared and 2. Right. If you have x squared and 2, you multiply them, you get 2x squared. Okay, we have x
yes,
squared and 2, then you have 2x squared. All right, with the 2x squared, now you look for the factors of 2x squared, that will give 3x.
yes.
What are the factors of 2x squared that will give 3x? Or like factors of 2 that will give 3. Right, factors of 2 that will give 3, you can imagine a 2x and an x. 2x and an x. And then 2x plus x. 2x plus x, if you add them up, 2x plus x, you get 3x. Like a 2 plus 1, you can add the coefficients. 2 plus 1 gives us a 3. And then in the end, then you have x squared, and then you have 2x plus 2, and this gives 0.
Okay.
This gives 0. You get the point?
Yes.
Okay, then we continue. Then we have the following. After this, then 2x plus x is 3x. So we've been able to break down the 3x into a sum of things, sum of terms. And then what we do is we factorize from these 2. X plus 2. X plus 2.
Mm.
Okay, so x plus 2, x plus 1. Okay, so you have this. Okay, so we divide the board like this. And then now it means the factors of this thing, x squared plus 2x plus 2, x squared plus 3x plus 2.
Mm.
These are the factors. X plus 2 open in
Okay.
brackets times x plus 1. Okay, yeah, you can find there are quicker ways, but you see, many times when I was taught then myself in school, the
Mm.
teachers would just say, when you need to factorize this at the time that I was taught, and it's only when I read other books that I realized, you know what? There are smarter ways of doing factorization, and I think that we were not taught very well. And obviously, we can always find reasons to criticize your teachers to say, you can criticize your parent and say your parent did not raise you well. I mean, whoever is perfect, I think that kids always people have a reason to complain.
Yes.
So yeah, it happens. So now everybody complains. They're like, I'm blaming my teacher. Some people blame God himself. Okay. Now with the
Yes.
factors of x squared plus 3x plus 2, what have the teachers said now? What are the factors of x squared? Then you put x and x. Then now you think of
Mm.
factors of 2 that will give 3. Factors of 2 that will give 3. And there are 2 and 1, but there's a plus everywhere, so you can put plus and plus here. But indeed, if you multiply this, it
Yeah.
becomes x plus 2 in brackets and then times x plus 1, which is sort of the thing we got. Exactly the thing we
Yes.
got. And then now, what are the values of x? And then you get that x is -2 or x is -1. So the -2 or -1 are sort of the correct answers to this. And then it would have been, if somebody would think that this x is positive x, it would have been not correct, because indeed both values of x are negative. We can see that x is -2 or x is -1, meaning that indeed this x should be treated as negative. But we can't in the beginning before we solve, because you can't
Yes.
know. It's
We
a
can
variable.
treat it as okay.
Yes.
So in the beginning, we shouldn't treat it as a positive or a negative. We should leave it like that
Yes, we should
until
leave
we
it that
get
way.
the final answer.
Yes, 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 yes. Most
Okay.
definitely. Most definitely.
Yes.
So we continue then.
Mm-hmm.
We continue then. So now, if you look at right, right. Okay, let's do the next thing. So we did 2.3.1 quite. We spent some time on it. Let us do 2.3.2.
Okay.
Let us do 2.3.2. We have this one, a plus 3, 24. We need to solve this one. What do we do? We continue.
Yes.
Okay, yeah, what do we do here? We need to solve for what? For a.
For A, yes.
Multiply this and that. Multiply this and that. Multiply this and that. Multiply this and that. Okay, so what do we do?
A, it's still A. It's gonna be A squared. It's
Yeah,
one. It's A1. It's
yeah,
A1 times A1. It's gonna be 8 squared.
yeah.
Yes. And A multiplied by 3. It's A3.
Okay, good,
Am
good,
I right?
good. Most definitely.
Okay. Then we go on the second one. 7 multiplied by 8. It's 7 A's.
Yes. Yeah,
And then
okay,
7
yes,
by
okay.
3.
So we deal with the first
Yes.
outers,
Yes.
iners, and the last.
Yes.
What is a by
The
a?
yes.
A
A
squared.
squared.
And then
Yes.
a times 3 is 3a. Then
3
minus
A's.
7
Yes.
times a is minus 7a. And then we have minus 7 times 3 is what? Is minus 21. And this equals
21
24.
A's.
And then
Yes.
this is a squared. What is 3a minus 7a?
It's 10 A's.
Okay, because the signs are different. The
Yes.
signs are different. So you take the sign
The
of the
sign of
bigger
the
number.
bigger number. Sorry. You
Yes.
take the sign of the bigger number, then you
And
minus.
from the bigger number, you minus the smaller number. Okay,
Yes.
so now we
And
then
then
say 7 minus 3. What is 7 minus 3?
it's 4A.
Right, then we have minus 21 minus 24 equals 0, which means s squared minus 4a minus 45 equals 0. Okay, now the minus 21 minus 24 is minus 45 because they have
45.
the
Yes.
same sign. You take the common sign and then you add the numbers. You take the common sign, which is
Add.
negative, and then you add the two numbers. You have 21 and 24. You get the point?
Okay.
So we
Yes.
continue. We continue. Right, then what are we able to achieve here at this point? What are we able to achieve here at this point? Right. Right, so continue. Okay, we continue.
Yes.
Right. Right. Okay, we'll continue, yeah? Okay, now to deal with this now, we need to factorize this. What do we do? Okay, we multiply the a squared with minus 45. And you get minus 45a squared.
Okay.
We multiply the a squared with minus 45 with minus 45a squared.
Yes.
And then we look for factors of minus 45 that give minus 4. They
Okay.
are right. So, but now right, yeah. What are factors of 45? There are two numbers. When you multiply, you get negative 45, but when you add them up, you get minus 4. What are those two numbers? Factors of 45. So you must break down the 45. We know that we have minus 9a and 5a. Right, minus 9a and 5a. Right, and then now if you add them up, you have a squared minus 9a plus 5a minus 45 equals 0. Okay, because minus 9a plus 5a is what? Is minus 4a.
Mm. Yes, it's minus 4a.
Yes.
4a.
And
Yes.
then you pull out a, and then you have a minus 9. You pull out here with a minus 9.
Mhm.
And then now you take the common factor. Okay, we deal with the common factor here. What's the common factor? So you cross this out and this out.
Yes.
We have a minus 9. We have a plus 5 equals what? Equals 0.
Yes.
Okay, which means therefore that a is 9 or a is what? It's a minus 5. Okay, a is 9 or a is minus 5. You see that? Okay,
Okay.
yeah, this gives us sort of the answers to the question. Would a be regarded as negative or positive in the original expression? The truth is a is a positive 9 or a is a negative 9. And this is what we're getting. This is exactly what we're getting. This is what we're getting. And we move forward, we move forward. We move forward. We move forward and we get the following. So if a is 9 or a is minus 5. Okay. So yeah, that's what we're getting. So that's what we have. Okay, this is the answer to the question 2.3.2. That is the answer to question 2.3.2. So yeah, so think about it and make sure you sort of understand what is happening.
Yes.
And then we have the following. We have the following. So look at the next thing. We look at the next thing. Okay, so let's look at the next one. Okay, we're gonna recap on this one on Lindo. Lindo is a good person, but decided to buy a K10 material, some of which, okay, is a popular kind of question, this, in this module. So there's a K10.
This, I'm sorry.
Yes.
On the other recording,
Yes.
I think we did it, this Lindo.
Yeah, definitely we did that. But
Yes.
but yeah, definitely on the other recording we discussed the Lindo. But I want us to break it down differently and
Okay.
include an analysis that is more elaborate, but that is a laid back sort of discussion.
Okay.
Laid back sort of what? Discussion.
Discussion.
Right. So what we then do is to then say, Lindo purchased 12 meters of curtain material, some of which had a slight flow and was priced at what? Okay, yeah. So Lindo purchased 12 meters of curtain material. So this was what? 12 meters
Yes.
of curtain material, some of which had a slight flow and was priced at 21 rand per meter.
Yes.
Was priced at 21 rand per what? Per meter.
Per meter.
Instead of 24 rand per meter. So obviously what we're dealing with here, we have this curtain material. Some of it is having some holes and it's nasty, part of it.
Mhm.
And now, but yeah, but it's all in all is what? Is 12 meters.
Yes.
All in all is 12 meters of curtain material, some of which had a slight floor and was priced at 21 rand per meter. Okay. 21 rand per meter. So now this one that is a slight floor was priced at 21 rand per meter. So yeah, 21 rand for the one that is having holes and is damaged and is flawed, this part. Right. And then
Yes.
instead of the 24 rand per meter, the one that is nice is 24 rand per meter. 24 rand per meter, and this one is 21 rand per meter. Lindo paid a total of 280 rand and 50 cents for the material. Okay. Yeah, Lindo paid a total of what? 280 rand and 50 cents for the material.
Yes.
So now let's take a look at this. Now, this is a total payment. Determine how many meters of flowed material Lindo bought. Okay, we want to know this one that is flawed. How many meters of it was there? The one that is damaged. Because some of it is nice, but some of it is damaged, having some holes in this curtain. So now Lindo knows, because it's a person who, you know, who does this kind of dressing and designs materials. He started, okay, I'm going to deal with it. I can cut the part that is flawed, you know, and leave the other part. But now determine how many meters of the flawed material. So what we do is, because overall it's X, overall it's 12 meters, this, because Linda bought 12 meters of the curtain. So now we can call this one X, that is from here to there. And then what would the other part be if this one is X? So the other one is going to become 12 minus X. The other one is going to become 12 minus what?
Minus X.
Okay, so if one part is 2 minus X, the other one becomes 12 minus X. And the other one is just what? The other one is just X.
Yes.
So that in the end, what do we get? Okay, in the end, then we deal with the fact that the one that is okay, the perfect part is 24 rand per meter. So that now you'd have 24 rand. Okay. 24 rand multiplied by 12 minus X plus, okay, just another student, just, okay, never mind.
Okay.
So right, so right, right. Right. Okay, we continue, please. I'm just trying to respond to this
Okay.
here. Okay. Right. So now we then have the following. And then you have 21x. Okay, so we have 24 into 12 minus x, and then 21x is equal to the total, which is 28 Rand 50, or 280 Rand and 50 cents.
Mm.
Okay. So now we take the amount of money for the, with the 24 Rand for the good curtain, for the good part of the curtain, and multiply the 24 by 12 minus x. And then we have the one that is damaged, flawed, slight flaws. In there is 21 Rand. It's made cheaper to 21 Rand and then multiplied by x. And the x is therefore the length of the curtain. That is what? That is a slight flaw in it. It has a slight flaw in it. So let us multiply everything together. Let's use our calculator. Here's our calculator. So you'd have 24 by 12. 24 by 12 is 288.
Yes.
Yeah, 288. So you're going to have here exactly 288 minus 24x, 21x, 280.50. Minus 24x plus 21x. 280, 50, 288.
Okay.
So,
sorry, one moment.
yes.
The 3x comes from the 24 minus 21x, right?
Yes. What is minus 24x plus 21x? We take the sign of the bigger number. 24 is
bigger number.
And therefore we take the sign of the negative of the bigger number, which is negative. And then 24 minus 21 is 3.
It's negative 3x.
Yes. So then we have 280.5 minus 288. Right. So which is minus 7.5. Yeah. Yes.
Okay.
Minus 7.5. Yeah. You're getting minus 7.5, and then need to solve for x, which is minus 3x. You divide by negative 3, and you have minus 7.5. You divide by negative 3. And then what is minus 7.5? Okay. Then you have 7.5, and you divide by 3. What do you get? Which is 2.5. Which is exactly 2.5. Which is 2.5. Which is exactly 2.5. Right. So x is what? X equals 2.5.
Yes.
Determine how many meters of the flawed material. So it means that the flawed material, the one that is having some holes in it, we called it X.
Yes.
And therefore, it means it must exactly be what? 2.5.
2.5 meters.
2.5 meters. And then what is the good one? Yes?
This solution is better than the one we did previously.
I think so. I think so. I think it's a bit more
Yes,
practical. It's a bit more practical.
yes,
Okay,
yes,
because we included the drawing here. Okay,
yes.
but also we can ask another question and say, X is the length of the float curtain. What about the good curtain?
So you're gonna take the 12 meter
Yes.
and minus the 2.5.
Well done. You're going to take the 12 and minus the 2.5, right? So now what you can call the good curtain, the good curtain is going to be actually 12 minus 2.5.
Yes.
All right. And what is 12 minus 2.5? Okay, you can use your calculator.
9.5 calculator. Yes.
Well done, well done. Wow, that's brilliant. Anyhow, I know, I mean, you're right.
Okay.
You're right. Your 9.5 is correct, but I'm glad that you just did it off the top of your head like that. Because you just gave it so quickly.
Yes.
Okay. But it is indeed 9.5. 12 minus 2.5 is indeed what? 9.5.
Yes.
So you have here 9.5 meters. 9.5 meters. Like that.
You are breaking.
Am I breaking? My apologies. My apologies. I think that's...
Hello.
Yes, hello. Right.
Yes.
Today we had a fair chance of some better communication. I think that, we're not breaking so much today.
Okay.
For a greater part of our discussion, I'm sure that I wasn't breaking so much. It was awesome having this discussion. We've just gone beyond 8, and I'm sure that
Yes.
it's exciting that we have had this discussion. We will actually most certainly see
Hello.
what to do. Yes, please. Am I breaking?
Yes, you are breaking.
Okay, yeah. Please forgive me. Forgive me for actually breaking. So
Yes.
then, yeah, we've reached the end of our discussion.
Yes.
So yeah, we shall discuss it again. You will let me know when you're free again, and then we'll make time available. Okay.
Okay. I
Right.
will let you know over there the WhatsApp, because right now we are breaking and the dog is barking. So
I understand.
I'll let you know over WhatsApp.
Yes, we'll talk.
Okay.
Yeah, we'll talk
Can
on
you
WhatsApp.
please also
Yes.
Can you please also send me the previous short recording that we had?
Oh yes, because
know.
yeah, because it was short and it was, so I was like, I did not even send it. I was demotivated to send it because it was recorded, but it was
No.
short. It was cut short. It was cut short.
No, the reason I wanted it's because
Yes.
you've done different example as to this one on the
Yes.
2.1. Yes.
Yes,
So
I
I
understand.
wanted to have both of the examples.
Okay, that's fine. That's perfect. Okay, I'm gonna make it available then. Okay. Okay,
All right.
thanks, yeah.
Thank you.
Thanks, yeah. It was awesome
Bye.
having this discussion. Until next time, take care. Goodbye.
Okay, bye.
Right, goodbye.